Hello everybody, my name is Benson Chu and I am a compiler engineer at Texas Instruments. In today's lightning talk, I will be going over a flaw that I found in the heuristic used by the MachineOutliner LLVM pass, which leads the outliner to increase code size when the goal is to decrease. I'll also briefly go over the fix that I implemented and my future plans for this fix. So, a brief overview of what the MachineOutliner pass is. Basically, you can think of it as like a reverse function inliner. The MachineOutliner will hunt around for sequences of instructions that repeat. For instance, in this example, we have this sequence, which repeats 3 times in this example, and the outliner will attempt to pull that sequence out into its own function and then replace each of the instances of that sequence with a call to this new function, as long as it reduces code size. So that's what the outliner does. So we'll talk a little bit about the heuristic of the outliner. So basically the way the heuristic works is it's just a raw instruction count of how many instructions are in the object file, with some size constraint, with size computation thrown in there. So for instance, in this example here, we have the object file libc, which has 3 functions, and they all share a common sequence. And then on the right is what it would look like if the MachineOutliner were to actually perform this outline. Now, unoutlined, this object file takes up about 15 instructions. But when we perform this outline, we get it down to 13 instructions. So great, the outliner thinks it's a good thing to outline. But unfortunately, this heuristic doesn't tell the full story. Let's bring in our main function here. If our main, so here we have a main function that links against one of the functions in the object file called f. If we link from the unoutlined version, then we only pull in about five extra instructions. However, if we link with the outlined version, then we end up pulling in 7 instructions. So clear. So okay. And this is because when we pull in the function f, we end up pulling in lambda, and what ends up being pulled in is not only the 5 instructions that used to be part of f, but also 2 extra instructions that were used in order to generate this outline. So does that mean it's always this is always a bad decision? Well, not necessarily. Let's say we bring in 2 functions from libc. If we bring in 2 functions, say f and g, it actually doesn't make a difference whether we outline or not. It will always generate the same amount of instructions pulled in. And lastly, if we pull in the 3rd function, function h, here is where we see the benefit that the MachineOutliner was seeing. So clearly the number of instructions in the translation unit doesn't tell the full story when it comes to whether or not the final binary will reduce in code size. In particular, we had this weird customer code come back that was pulling in like one variant of an outlined function from from many different object files. And for every time that they pulled in one of these outlined variants, the instruction count would increase by 7 if they had the outliner turned on. This is not great, so something had to be done about this. And what I eventually decided on was introducing a new mode to the MachineOutliner that was a lot more pessimistic. And I'm choosing to call this dichotomy InterFunction versus IntraFunction outlining. InterFunction is basically what we had before, where if the outline reduces the size of the translation unit, then we will do that outline. However, on the other hand, IntraFunction outlining will only perform outlines that are guaranteed to not increase the code size of the final binary. Basically, the way this works is that it'll calculate its heuristic on a per function level to make sure that no function that is outlined will increase the code size if it's the only function that's being brought into the link. This doesn't mean that InterFunction outlining is always a worse option, particularly in a context like LTO when you already know everything that's going into the final binary. the aggressiveness of interfunction outlining actually excels in an environment like this. So the heuristic function for intra-function outlining looks like this, and I'm not going to explain it. And this heuristic function will basically tell us to not outline, in this example, not outline F and H, but outlining G is a good option. And we end up with something that looks like this. Now, we only reduce an instruction count by 1, but versus if we had outlined everything, we would have lost 7 instructions. But the difference being is that it doesn't matter what combination of functions that we decide to pull in, we'll always either do the same or better than if we had decided not to outline. So these are the 2 command line options that I added to the compiler in order to inform the outliner of how aggressive to be. And yeah, that's basically it. I haven't started the upstream process on this yet, so unfortunately I can't point you to a place where you can go and see the code. I would prefer to make intra-function outlining the default option for the compiler, but that means I need to go and change a bunch of tests, which I'm currently in the middle of doing. Also, I'm open to the idea of changing my mind about this because the aggressive outliner does help in most scenarios. It's just we ran into a few edge cases where benchmarks were regressing, so I had to add this option. But that's basically it. If you would like a sneak peek of the diff, or if you have some questions, feel free to send me an email. Hope you learned something.